In the opening seconds of this story, imagine a lone P-38 Lightning diving hard through the clouds over the Pacific. Its twin engines scream as the pilot pushes the aircraft past its limits. Behind him, 3 Japanese Zero fighters close in. The Zero was famous for its agility, unmatched turning ability, and deadly precision. Every pilot in the Pacific knew that if a Zero got behind you, it was almost over. But suddenly something unbelievable happens. Instead of getting caught, the P-38 snaps into a tighter turn, tighter than the Zeros. The Japanese pilots are stunned. The Lightning should never have been able to do that. But it did. And that impossible maneuver wasn't the work of a factory upgrade or a top-secret engineering team. It came from the hands of one frustrated American mechanic who used nothing more than a piece of wire, a pair of pliers, and an absolutely stupid idea that no one believed would work. Yet this simple trick changed the way P-38s fought in the Pacific and helped American pilots survive battles they should not have survived. The story really begins months earlier, when the P-38 Lightning was first deployed into the Pacific theater. The aircraft was fast, powerful, and heavily armed, but it had one major problem. It was never meant for tight-turning dogfights. The Lightning had long wings, 2 engines, and a complicated control system that made it slow to respond at low speeds. In straight-line speed, the P-38 could outrun the Zero in climbing. It could outclimb the Zero. But when the Japanese fighter forced the P-38 into a slow, turning fight, the outcome was predictable and deadly. American pilots quickly discovered that the Zero could turn inside them every single time. Squadron reports kept coming in. We can't shake them. They turned tighter. Rolling response too slow. The brass heard these complaints, but the engineers were thousands of miles away and couldn't redesign the aircraft in time. In the Pacific, pilots needed a solution immediately. Something had to change, or the P-38 would keep losing. This is where the mechanic enters the story. His name is rarely mentioned in official records. He wasn't a senior engineer, he wasn't a famous ace, and he definitely wasn't someone the commanders ever expected would influence the course of air combat. He was just a crew chief, one of the thousands of men who worked day and night under the sun, maintaining fighters in jungle airstrips. He had seen too many pilots return frustrated, complaining that the P-38's controls were just too stiff in combat. He had seen bullet holes in wings, shredded control cables, burned engines, blown tires. And he had seen pilots who never returned at all. After one particularly rough mission, when a young pilot barely survived being chased down by Zeros, the mechanic decided he couldn't just sit back and wait for an official solution. The P-38 had a specific problem. The ailerons and tail control surfaces became stiff under high-speed airflow. This made the aircraft less responsive, especially during turning or evasive maneuvers. The mechanic spent hours inspecting the control linkages, watching how the surfaces moved, and thinking about ways to reduce the mechanical resistance. The official manuals gave no answers. The factory engineers warned crews not to modify anything. Commanders didn't want creative ideas that could risk damaging planes worth hundreds of thousands of dollars, but the mechanic didn't care about rules at that moment. He cared about the pilot he had nearly lost that day. He cared about the men risking their lives while he stood on the ground. Then one night, while sitting alone under the wing of a P-38, he noticed something simple. One of the control springs, a tiny component that helped stabilize the ailerons, seemed overly tight. It made the controls feel stiff, even when the aircraft was on the ground. The mechanic thought to himself, what if the spring could be loosened, or bypassed, or balanced with something else? A stupid idea crossed his mind. What if he used a piece of wire to slightly change the tension on the spring, giving the pilot more flexibility in the controls? It wasn't a recognized fix. It wasn't in any manual. In fact, if anyone saw it, he could have been written up for unauthorized modification. But he tried it anyway. He took a thin but strong steel wire, left over from securing engine panels, and threaded it around the spring assembly in a specific loop. Then he twisted it tight using just a pair of pliers. The wire added a counter tension to the spring, effectively reducing the stiffness of the control system. It wasn't elegant, it wasn't official. It was field improvisation at its purest. When he showed it to another mechanic, the response was immediate. That's the stupidest thing I've ever seen. Even the pilot who was supposed to fly the next morning looked at it with doubt, but he agreed to try it. The next day, the pilot took off. As he gained altitude, he immediately noticed something different. The ailerons felt lighter. The controls responded faster. The aircraft rolled more quickly. It wasn't dramatic, but in dogfighting, even a small improvement could mean life or death. He radioed back to the mechanic. Feels different, feels good. But the real test came an hour later when enemy planes appeared on radar. A formation of Japanese Zeros swooped in, expecting the same slow-rolling P-38 they had tangled with many times before. But when they forced a turning engagement, the Lightning responded faster than expected. The pilot pulled the aircraft into a sharper turn than he had ever managed before the Zeros overshot. Suddenly, the P-38 wasn't struggling to survive. It was taking the offensive. When the pilot returned to base, he jumped out of the cockpit almost before the propeller stopped spinning. He ran straight toward the mechanic. "What did you do to my plane?" he shouted, not in anger, but in absolute disbelief. "It turns better, rolls faster, it feels alive." Word spread across the squadron within hours. Other pilots wanted the wire trick. Some mechanics laughed at it. Some dismissed it. But the pilots, who were the ones facing death in the air, wanted every advantage they could get. Soon, more planes were modified, and the results kept coming in P-38s that had always struggled in tight-turning fights now had a chance. They still weren't as maneuverable as Zeros, but they were no longer helpless. They could roll faster to break enemy attack angles. They could snap into quick defensive turns. They could escape traps that once doomed them. It wasn't long before squadron commanders noticed. Some were skeptical until they saw the performance difference themselves. One commander, who initially called the idea ridiculous, later requested the trick for every plane in his unit. By the end of the month, dozens of P-38s in the region had the wire modification installed. Pilots even reported that Japanese fighters were being caught off guard by the Lightning's improved agility. For the first time, the P-38 wasn't just a fast interceptor, it became a more flexible dogfighter. And all of it started from a mechanic's late-night idea that everyone initially thought was stupid. Back in the United States, when engineers finally heard about the field modification, they were shocked. Some argued it was unsafe. Others argued it was untested. But frontline data didn't lie. The planes were performing better, pilots were surviving more encounters, and the Japanese were no longer exploiting the same weaknesses. Eventually, improved control systems replaced the wire trick, but by then, its effect had already helped change the tactical balance of the air war. And the mechanic? He never became famous. His name never appeared in newspapers. But for the pilots whose lives were saved because their aircraft could now outmaneuver the most feared fighter in the Pacific, he became a quiet legend. As word of the wire trick began spreading through the P-38 squadrons, most people still didn't understand why such a simple piece of metal could make such a big difference in aerial combat. To the pilots, the improvement was obvious. They could finally control their aircraft in ways they had never experienced before. But behind this surprising success was a deeper mechanical problem that had affected the P-38 from the moment it entered combat. In this section, we look at why the Lightning struggled so much against the Zero, what made the Japanese fighter so dangerous, and why no official solution had been delivered before one mechanic finally changed everything. When the American pilots first encountered the Zero in the early months of the Pacific War, they were shocked. The aircraft was unbelievably maneuverable. It turned so tightly that pilots joked it could almost turn inside its own propeller. Its light frame, large wings, and responsive controls allowed it to snap into tight rolls and sudden direction changes that no American fighter could match at that time. Even experienced pilots who had flown in Europe felt unprepared. They simply had never faced anything like the Zero before. It had weaknesses, like poor protection and vulnerable fuel tanks, but in a dogfight, especially a slow, tight-turning battle, it was the king of the sky. The P-38 Lightning, on the other hand, was a completely different kind of machine. It was powerful, fast, and built like a tank. Its twin supercharged engines gave it incredible climbing speed, and its long-range capability made it perfect for the vast distances in the Pacific, but it was designed for high-speed interception, not tight-turning battles. When a Zero forced the fight into a turn, The P-38's wide wingspan and stiff controls made it sluggish. It simply couldn't keep up. Pilots quickly learned that if they allowed a Zero into a turning fight, they were in trouble. Many early P-38 losses happened exactly this way. Pilots didn't know their aircraft's limits yet, and they tried to fight Zeros the wrong way. In theory, the Lightning's design allowed for precision control, but in practice, the aircraft suffered from a problem that engineers called control compression. When the P-38 flew fast, especially during dives, the airflow around the wings increased dramatically. This airflow pushed against the control surfaces, ailerons, elevators, and rudders, making them harder to move. The pilot had to use more force to adjust the aircraft. At even higher speeds, the controls could become so stiff the pilot struggled to move them at all. Engineers back in America were working on improvements like boosted controls, but those upgrades were months away. Meanwhile, real pilots in real combat had to fight an aircraft that didn't respond fast enough when a Zero got behind them. This problem was even worse during the chaotic, violent dogfights over the Pacific. The pilots were constantly pushing the aircraft to its limits. If the P-38 couldn't react fast enough, the pilot had no chance to escape an enemy's firing position. This stiffness wasn't just annoying, it was killing pilots. But on the ground, mechanics saw the issue from a different angle. They didn't have wind tunnels or advanced test equipment. What they had was experience. They worked on the control systems daily. They felt how the linkages, pulleys, and springs behaved. Many mechanics agreed that the controls felt too tight, even without aerodynamic pressure. The aircraft simply wasn't giving the pilot enough mechanical freedom. And that observation is what brought the mechanic in this story to his stupid idea. Before the wire trick, the official thinking was that only engineers could solve the control stiffness problem, and only with complex redesigns. But engineers weren't on the front lines. They weren't watching pilots fight for their lives. They weren't seeing the difference a tiny adjustment could make. The mechanic who invented the wire trick had spent months inspecting the same components. He noticed how a small spring in the control system was pulling harder than necessary. The spring was meant to create resistance and stability, but it was doing too much. It made the ailerons feel heavy, even before the plane left the ground. And in combat, that weakness robbed pilots of precious milliseconds. At that time, no one would have taken the mechanic seriously if he had reported this observation. Aircraft maintenance followed strict rules. Deviating from procedures was risky. But this mechanic didn't care about rules. He cared about pilots. He remembered the day a young pilot returned from a dogfight, shaken and pale, barely landing his plane after being chased by Zeros. The pilot's biggest complaint wasn't fear, it was frustration. "The controls are too damn slow," he had said. That complaint stayed in the mechanic's mind, and it's what pushed him to spend long hours studying the control system. Even after his official duties were done, the wire trick didn't come out of sudden inspiration. It came from weeks of quiet observation, problem solving, and the desire to keep pilots alive. The mechanic tested different ways to ease the spring tension. He considered removing the spring entirely, but feared it would make the controls unstable. He thought about replacing it, but he didn't have a suitable part. Then he thought about balancing it. If he could create a counterforce without removing the spring, maybe he could get the perfect middle ground. Lighter controls that were still stable. The idea seemed ridiculous to many mechanics because it went against the usual methods. Instead of replacing a part, he was modifying the tension using something as basic as wire. Aircraft modifications required approval, documentation, and testing. But this wasn't an official modification. It was improvisation born out of necessity. When he installed the wire threaded carefully through the spring assembly, he knew he might be risking a reprimand, but he believed it would help. And when the first test flight proved him right, everything changed. The moment pilots realized the trick worked, their confidence in the P-38 grew. For months, they had flown cautiously, knowing their plane couldn't turn fast enough to shake a Zero. But now they had a fighting chance. The aircraft responded faster, it rolled quicker. It snapped into evasive maneuvers that were impossible before. And even though the P-38 still wasn't a Zero, it could surprise the enemy in ways the Japanese pilots never expected. The Japanese pilots were taught to rely heavily on the Zero's turning superiority. They were used to American fighters being slower in rolls and sluggish in tight maneuvers. So when a P-38 suddenly turned sharper than expected or rolled faster to evade fire, they were momentarily shocked. In air combat, a second of hesitation is deadly. Many Zero pilots paid for that moment of surprise with their lives. Reports from P-38 pilots started to reflect this shift. The Zeros are not outturning us as easily anymore. Rolling response improved, could escape a tight position today. Even commanders who originally dismissed the modification as nonsense had to accept that something real was happening. Tight turn capability was not magically transformed, but it was improved just enough to matter. And sometimes that's all survival requires. Soon the wire trick spread from squadron to squadron. Some mechanics improved the method, adjusting the placement or tension of the wire, making it more uniform across planes. Others documented the modification quietly, so new ground crews learned it as an unofficial but essential upgrade. In many squadrons, it became standard practice. Pilots began requesting it before even flying their new aircraft, and those who had flown without it could feel the difference instantly. Despite all this success, not everyone approved. When higher-level engineers finally heard about the modification, they worried it might cause long-term mechanical problems. They argued that an unofficial fix wasn't safe, but pilots and mechanics pushed back. They didn't care about paperwork, they cared about results. And the results were clear. Fewer pilots were dying, and the P-38 was finally able to fight on more equal footing with the Zero. The mechanic who invented the trick never expected his idea to spread across the Pacific. He wasn't looking for praise, he simply wanted to solve a problem. And even though he didn't redesign the aircraft or create a new part, his tiny adjustment made the difference between life and death for countless pilots. In a war filled with massive battleships, advanced radar systems, and massive engineering projects, sometimes the simplest solutions, created by ordinary people, could have the biggest impact. Once the wire trick started appearing on more P-38s, the real transformation began in the day-to-day operations of the fighter squadrons. But making the modification work across dozens of aircraft wasn't simple. Every plane was slightly different due to wear, repairs in the harsh Pacific environment. Sand, humidity, and rough airstrips constantly damaged cables and linkages. Mechanics had to adjust the tension of the wire very carefully on each aircraft so the controls felt balanced. Too loose, and the improvement was barely noticeable. Too tight, and the ailerons could flutter or feel unstable in flight. This part of the story is where we see how frontline war innovation actually works, not through a single big idea, but through hundreds of small adjustments, trial and error, and teamwork between pilots and mechanics. The first challenge came from standardizing the wire trick. The mechanic who invented it had created the modification by instinct, not by design blueprints. When other mechanics tried to copy it, many struggled to get the same result. Some wired it in the wrong place. Others applied too much tension, and a few simply didn't understand what the wire was supposed to do. Pilots flying those early attempts came back with mixed reviews. Some said the controls felt amazing, while others said the improvement was small or uneven. Mechanics gathered at night under dim lamps, comparing results and sharing observations. It was like a secret workshop where each crew chief contributed a small improvement. Slowly through teamwork, the wire trick evolved from one man's creation into a reliable field modification. Pilots became an essential part of this process. They provided constant feedback, sometimes right after landing with sweat still on their faces from combat. P-38 pilots were famous for being very close to their ground crews. In the Pacific, survival depended on trust. Pilots trusted their mechanics more than anyone else. They knew their lives were literally in the hands that tightened bolts, calibrated guns, and inspected engines. Now that bond became stronger than ever. After each flight, pilots described in detail how the controls responded, whether the plane rolled fast enough, whether the turn felt stable, or if the plane shook during evasive maneuvers. Mechanics used every piece of feedback to refine the modification. Little by little, the wire trick became more precise and effective. One dramatic moment occurred in a squadron that had recently received new replacement P-38s. These new Lightnings had been damaged during shipping and required major repairs. Their control systems felt heavier than normal. When the mechanic tried the wire trick on the first one, it barely had any effect. Days passed as the ground crew tried variations. Different wire thicknesses, different loop positions, different tension. The pilots were anxious. Japanese Zeros had been increasingly aggressive in their area, pressing attacks at dawn and dusk. The squadron needed their P-38s to be responsive. One morning, after nearly a week of adjustments, a pilot took off and tested the latest version. He returned after 30 minutes with a huge grin. "That's it. That's the sweet spot," he shouted. That moment set off a wave of motivation across the flight line. Within 48 hours, the entire squadron had fully calibrated wire modifications installed. As the P-38's roll rate and turn response improved, pilots began experimenting with new tactics they had previously avoided. Before the wire trick, P-38s tried to stay out of tight dogfights, focusing on boom and zoom attacks, diving on enemy planes and climbing away before the Zero could react. But now, with more responsive controls, pilots gained confidence to try defensive barrel rolls, slashing turns, and energy-retaining spirals that previously felt too dangerous. One pilot described the change perfectly. "Before the fix, fighting a Zero felt like wrestling underwater. After the fix, it felt like my plane could finally breathe." This new agility didn't make the P-38 superior to the Zero in turning, but it gave pilots something equally important: options. In aerial combat, having more options is the difference between life and death. The Zeros could no longer predict exactly how a P-38 would respond. A lightning under pressure could roll suddenly to one side, snap into a brake turn, or make a high-speed split-S maneuver with much more control. Japanese pilots, trained to exploit predictable weaknesses, were caught off guard. Their greatest advantage, superior turning, was now less reliable. Many Japanese after-action reports from 1943 and 1944 mentioned P-38s maneuvering more sharply than expected, or evading attacks in unusual ways. These small tactical surprises accumulated over time, shifting the balance in the air just enough to matter. Word of the modification traveled fast. Some pilots carried handwritten notes with diagrams of the wire trick when they visited nearby squadrons. Mechanics traded tips back and forth when meeting on supply trips. Even Australian and New Zealand aircrews serving alongside American units heard about the improvement and asked for demonstrations. The Pacific Frontline was a place where innovation spread virally, fueled by necessity, creativity, and survival instincts. If one squadron found a way to live longer in battle, every nearby squadron wanted that knowledge too. But while the wire trick spread, not everyone approved. Higher-level maintenance officers sometimes scolded mechanics for altering aircraft without authorization. They worried about long-term wear, metal fatigue, or unintended side effects. Some even ordered the wire to be removed during inspections, but pilots pushed back fiercely. Some refused to fly their planes unless the wire trick was reinstalled. One squadron commander openly defied an order to remove the modification, telling the inspector, "My men live in these planes. We'll keep what keeps them alive." Eventually, the resistance at the upper level faded, not because they changed their minds, but because the evidence was impossible to ignore. Combat reports clearly showed that P-38s with the wire trick survived dogfights that identical aircraft without it struggled in. As months passed, the wire trick's impact grew even larger during major campaigns. During missions over the Solomon Islands, New Guinea, and the Philippines, P-38 pilots relied heavily on their improved control response. In these dense, chaotic battles, the Japanese often attacked from multiple angles, forcing American pilots to constantly brake, roll, or dive. With the wire trick, the P-38s could shift their weight more quickly, avoid getting locked into turning duels, and reposition themselves for high-speed passes. Many pilots credited the modification with saving their lives when surrounded by enemy fighters. Some even wrote letters home describing the miracle fix that transformed their aircraft. One dramatic example involved a pilot caught alone above a cloud layer with 4 Zeros closing in. Before the wire trick, the outcome would likely have been fatal, but with quicker roll response, the pilot executed a series of defensive rolls, high-speed scissors, and brake turns that confused the Zeros long enough for him to dive into the clouds and escape. When he returned to base, he told his mechanic, "Your stupid wire saved me today." The modification even changed the way P-38s flew escort missions. When protecting bombers, Lightnings often had to react suddenly to enemy interceptors diving from above. With stiffer controls, these reactions could be too slow, but the improved control response allowed P-38s to intercept threats more quickly and position themselves to break up Zero attacks before they reached the bombers. Several bomber crews later reported that P-38 defense felt sharper and more responsive during this period, not realizing that a simple wire fix back on the ground was partly responsible. Even more interesting was how the wire trick began influencing larger tactical decisions. Squadron leaders started planning missions with slightly more aggressive maneuvers in mind, trusting their P-38s to respond well in tight situations. Pilots practiced defensive rolling drills with greater confidence. Some even trained for limited dogfighting, something they had largely avoided earlier in the war. The psychological benefit was enormous. A pilot who trusts his aircraft fights with more courage, more control, and more precision. But perhaps the most powerful sign of the wire trick's importance was what happened when upgraded factory parts finally arrived. New control boosts and improved components were designed to solve the stiffness problem officially. But when these parts were installed, many pilots said the change felt less dramatic than the wire trick had already delivered months earlier. The factory upgrade was more polished and stable, but the frontline innovation had paved the way. It had proven that agility mattered, that adjustments worked, and that pilots needed responsive controls now, not months later. By the time the war entered its later stages, the mechanic who invented the wire trick had already changed countless lives. He never sought recognition. He never filed a report claiming responsibility. He didn't view himself as a genius or a hero. He simply looked at a problem, felt the frustration of the men he served alongside, and acted. His stupid wire idea became one of the many small, unsung innovations that shaped the outcome of the air war in the Pacific. And it stands as a powerful reminder that in war, sometimes the simplest ideas, born not from laboratories but from dirt-covered mechanics working under tropical heat, can shift the balance more than anyone expects. As the war continued and the modified P-38s dominated the skies, the true impact of the mechanic's wire trick became clearer with every mission. What had begun as a small field modification inside a dusty airstrip workshop ended up reshaping American air strategy in the Pacific. Pilots who once feared close-range dogfights with Japanese Zeros now actively sought them out. Reports sent to command headquarters showed a steady rise in enemy losses whenever modified Lightnings were present. The numbers were so strong that high-ranking officers started including the improved P-38s in the most dangerous missions, confident that the aircraft would now perform at its full potential. What impressed commanders the most was that the fix required no new parts, no redesign, and no downtime. Just a few wires, properly tensioned, that transformed the controls entirely. As this secret circulated across airfields, more mechanics began repeating the modification, turning the once stubborn fighter into one of America's most lethal tools in the air. The Japanese, however, could not make sense of the sudden shift. They noticed that the P-38s were now rolling tighter, recovering from dives faster, and even matching them in low-speed turning fights. At first, they believed the Americans had introduced a new, upgraded model of the Lightning, but reconnaissance photos showed the same silhouette, the same engines, the same frame. The Zero pilots complained that the aircraft they had outmaneuvered for years had suddenly become unpredictable, capable of moves that defied everything they had learned in training. They wrote in their combat diaries that the Lightning now twisted through the sky like a much smaller airplane, and that fighting it had become far more dangerous. Many never discovered that their sudden disadvantage came from a fix so simple that it could be installed using ordinary workshop tools. By late 1944, the mechanic's idea had spread so widely that it was considered standard procedure in frontline squadrons. Pilots joked that the Lightning now felt like it had lost weight, even though the airframe had not changed at all. The wire system reduced control resistance so smoothly that younger pilots, fresh from training, assumed the P-38 had always handled that way. They never experienced the earlier version, the one where pulling out of a high-speed dive felt like trying to lift a heavy door with frozen hinges. Now, they were free to use the aircraft's full power and speed without fear that the controls would betray them in a critical moment. This confidence allowed American pilots to adapt new tactics, including aggressive diving attacks, snap roll breakaways, and tight defensive spirals that made it nearly impossible for enemy fighters to stay on their tail. The transformation of the P-38 had a deeper effect on morale too. The Pacific War was long, exhausting, and fought across endless miles of open ocean. Pilots knew that if their aircraft failed them, there was often no place to land, no friendly territory below, and no rescue if something went wrong. The improved handling of the P-38 gave them a psychological strength they desperately needed. Many pilots later said the modification made them feel safer, more in control, and more optimistic about surviving each mission. This emotional impact, though impossible to measure, played a massive role in keeping experienced pilots alive and effective. In a war where seasoned aviators were irreplaceable, the mechanic's idea helped preserve the very people who carried American air power forward. Even decades later, aviation historians still mention the P-38's wire trick as one of the most brilliant small improvements in aircraft history. They point out that giant factories produce engines, armor, and weapons, but sometimes a single mind on a frontline base, working with what he had, could produce a breakthrough no engineer had considered. The mechanic who invented the fix never sought fame for it. He remained humble, insisting that he only wanted to stop the aircraft from fighting the pilot. But his simple idea became one of the reasons the Lightning regained the advantage in the toughest skies of the Pacific. When the war finally ended and pilots returned home, many spoke about the P-38 with great respect. They remembered how the aircraft carried them through storms, through missions over deep ocean, and through fierce dogfights against some of Japan's most skilled aces. But what they remembered most was that moment when the modified Lightning first responded exactly the way they hoped it would. Fast, sharp, obedient, and alive. That single change gave them the edge they needed to outmaneuver the Zero and return home safely. In the end, the mechanic's stupid wire trick was anything but stupid. It was a reminder that in war, a small idea can save countless lives, tilt the balance of entire battles, and turn an already powerful weapon into a truly legendary one.